morning or afternoon or evening, everyone. Thank you so much for joining us. We are going to kick off the third installment of the Black Swan Project's Phase 1 in just a few minutes. But before we do, I wanted to share just a little bit about the Shaping EDU Winter Games. So I'd love to invite all of you to join us January 5th, 6th, and 7th. We've got a free change-making summit themed around the Olympic Winter Games taking place virtually. We'll be exploring smart technologies, overcoming tech fears, and answering this question or talking about this question of, so what comes next in a society sense, in a technology sense, in a humanity sense, education sense. I'll put a link in the chat for anyone who's interested about more information. But in the meantime, let's talk about black swans. So I'm going to hand it over to Ruben, who is a change maker and a Shaping EDU innovator in residence, the groundskeeper of Black Swan Lake. He is facilitating the Black Swan Project this year, where we explore together Black Swan thinking, anti-fragile thinking, and sort of this question of how do we use those to create. Ruben, take it away.
So, good morning or afternoon, everyone. Thank you all for coming from wherever you are in the world. So let me start out by saying that if you've been to the previous sessions, today's going to be both at once a sort of continuation and wrap up of the previous ones, but it's also going to set the stage for the next phase of the project. In other words, as we're going to see, this has been an intro, but next thing we're going to do is we're going to shift gears after today's session towards a studio mode, towards a mode in which we're going to be talking about saying, well, how do we use Black Swan thinking to actually design some practice? But we'll get to that in just a bit. So let me pick up where we left things off last time. Last time we had said, well, okay, we went from the very big picture. When you're thinking about groups of people or entities as these very big bathtub-like collections that aggregate all of these people or objects or entities, to something that was more on an individual scale where you had agents. And we saw that having agents, having those individuals, could change the rules of the game. But up to last time, we were thinking of those agents as largely unconnected. Maybe they could interact with each other, certainly. They would leave traces behind. But today we're going to start seeing, well, okay, so what happens if they are connected with each other? What happens if they are in a network? And as we're going to see, that can be at once the source of some of the most dramatic and most unexpected black swans, but it can also be the place where we find the most power to respond to black swans, to find solutions to black swans. So let's pick this up where we left things off last time, and let's start on a somewhat complex note in these days of COVID that takes things just a step further. You'll remember that last time we talked about thinking about, okay, so we have a pandemic, we could think about it in terms of very big pools of people who were healthy, infected, recovered, and then we looked at them from an agent perspective. So let me just very quickly, for those of you who weren't here last time, show you again what that looked like, because we're going to now make a small change. So I'm going to go ahead and share my screen here. Here we go. So if all goes well, this should allow me now to share with you. Okay, so you should now be seeing my screen. You should see Insight Maker. And I'm going to go to the simple disease agent scenario. And I'm going to just go ahead and I'm going to run this, okay, just so you can see this in action. One second here. Okay. And sorry, let me run that again. what you just saw happen is what happens if you have absolutely nobody who's sick in the first round. That can happen when you have an agent model. It might be the case that one person gets sick, then gets well, and that's it. So you'll remember that we get something that's no longer quite so smooth. It starts looking wobbly, etc. And if we look at how the agents are looking, in this particular model, you might remember that we had people who started to go away from people who were infected. So there's no particular connection, but people recognize people who were infected, stayed away from them. So this is what the evolution of the disease looked like over time. All right. But here's the thing. In general, people aren't quite as loosely structured or as loosely connected, or rather not connected, as they are here. People here are just wandering around at random. But in general, people are connected to each other. They are in families. That's a connection. That's a network. They work jobs together with other people. That's a network. They ride the same bus with other people. That's a network. So one of the things you could start asking is, well, according to how people are connected with each other, can you start seeing differences in behavior that go even beyond what we had seen when we brought agents into the picture for the big models? So I'll close this out now. And again, just a brief recap for those of you who weren't here last time. I'm going to be using NetLogo for my tool here. And I'm now going to go to a new model that I had not shown before. And here we go. This is the NetLogo model for virus on a network. Incidentally, just for those of you who haven't been in the previous sessions, all of these resources, all of the software I'm using, every single link is going to be posted to a blog post after this session. So don't worry about not having the exact URL just now. You will get it as part of that for you to play with and look at later. So here we go, and we say, well, suppose we have a virus with the same characteristics. Some people get sick. Some people recover and become immune. Some simply recover but do not become immune. What does this look like? And I'm going to just show you very quickly what this looks like for a scenario like this one that you're seeing here, where you have a scenario where people are connected with each other. So for instance, you should see, if you look towards the top, you have here a group of 6 people that are much more closely connected to each other than anybody else is. This is towards the top center if you're looking at the diagram. And each of these little dots represents a person. Each of the lines represents a connection from that person to other. On average, there are 6 different connections going from each person, but I could set this to more or fewer, etc. And you can start to see certain structures appear. But let's go ahead and run the disease on this, and you'll see what happens as it runs over time. So you can see what happens. We start with a cluster that started there on the left side, for instance. Incidentally, all of this is random in this particular setup, so it would look different if I ran this at a different time. And you can see what's happening. The curve of blue dots, which are the people who are healthy, not infected, fluctuates. It doesn't go monotonically down. That has to do with who's there, how many people they're seeing who are infected. And notice that the people who recover and become immune, the gray dots, start to act as barriers. So they could stop propagation to a network, but whoops, looks like it leaked out anyway. It made it now, so you're seeing some people on the right-hand side. And notice that the curve that you're seeing in that network status plot is much more complex than what you had before. So I'm going to stop this now, because what I would like you to do is, after this session is done, I would like you to actually go ahead and run this for yourself. In other words, rather than watching me run it with different parameters and so on, I would like you to test this. And you're going to find several things. For instance, you may find that changing the node degree by just a little bit can change dramatically how the disease propagates through the network. Changing how likely it is that somebody will become resistant changes dramatically how the disease propagates, what the curve looks like, where as time goes by, how many people become infected, etc. So this is a different type of behavior from what we saw before. And this is telling you where black swans start to occur. Because if you use a simple susceptible infected recovered model, and you don't factor in agents, you get the nice smooth curves and so on. And you start to get some black swans when you start to look at reservoirs for people coming from, say, one region that is infected to another. It's not, but overall, you still get those smooth curves. Add agents into the picture, you start getting some noise, you start getting some unexpected blips in propagation. You might have something that doesn't propagate at all, but add networks, and suddenly all bets are off. And I don't know if any of you read the New York Times this morning, but there's an excellent article on how having trains in India changed the connectivity of the COVID-19 propagation network, and changed dramatically, not just a little bit, not just said, well, it increased proportional. No, it just completely changed the network. And in changing the network, it changed completely, sadly, the rules of the game for how the virus propagated, and in turn, how many communities were affected and how badly they were affected. So this is where we're starting, just to look at the network and to be able to say, okay, clearly throwing in a network into the picture changes the rules of the game dramatically. I wanted to do this with the example I've been following all along, so you can look at this. Fine. But I don't want to leave it here. So at this point, I could start doing more models and showing you, well, we did this with the general system dynamics model, then we added agents, now we add networks. But I'd rather take this in a different direction. I want to take this in the direction of what I would call hope, because otherwise it starts to look, oh man, it looks like it's too complicated. It looks like it's too difficult to do anything. It looks like as soon as we throw networks into the picture, well, all bets are off. We might as well go and get a nap somewhere because we can't do anything. And that's not the right way to look at this. So for instance, if I were to stay with simulation, I could start asking, well, what if I were to immunize people in this network? Suppose I don't have enough vaccine to immunize everybody. Could I use features of the network to pick who I would immunize, and therefore perhaps reduce the spread dramatically without having to immunize everybody in the network? Could I use this to perhaps predict which communities are going to have outbreaks, so I could get hospitals set up for those outbreaks? In other words, I want to take this in the direction of hope. But to take this in the direction of hope, I need to move away from modeling for a bit. And I need to talk about the language with which we talk about networks. Because I just told you, for instance, hey, look at this cluster of people that are more closely connected to each other than to the rest of it. Let me get some language there, and let me get some tools into your hands to talk about this. And one of the things I want to do is to actually have you, through today's session, do a couple of activities where you're going to be using this language, this conceptual tool set, to see how you can use this with students, for instance, to change something much less dramatic, perhaps, than stopping COVID-19, but nonetheless very important, which is how do you get collaborative projects to actually work in a community of students? I'm going to stop sharing for a second. Let's see. There we go. And let me check to make sure. By the way, if you have any questions at any point, please don't hesitate to type into the chat. I really want this to be, again, I've said this before for those of you who've been in these sessions, but I want this to be as useful to you as possible. All right. So we need to get some basic terminology in place. So we need to talk a little bit about what do networks look like with a couple of basic ideas. So let me get my whiteboard up here. Okay. And let's sketch a little bit. So the first thing we're going to say is, okay, so people are connected. So I have one person here. I'm going to call them A. And one person here. And I'm going to call them B. Okay, a little bit of network terminology. If I'm saying, hey, I want to have these two people represent a network, the term that's normally used to describe this are nodes on a network, okay? Because the term nodes would apply to people. It would also apply if you were talking about, say, train stations being connected on a network. It would apply to routers on a telecommunications network, etc. So that's just a little bit of terminology. And the other element I need to bring into the picture is to say, well, okay, so if the people are the nodes, how they are connected is, well, I'm going to represent this with lines. So represent it here with a line. And this is what we call an edge. So just a little bit of terminology, okay? So we have nodes and we have edges. Now, one of the things is you have to think a little bit more about how networks are constructed in terms of saying, well, all right, the edge is great. So if you connect two people, are they always connected in the same way? And I'd say, well, no, not necessarily. Suppose this is a network of parents to children, okay? If somebody is my child, I am not their child, so it's asymmetrical, okay? So we can say there are some types of relationships between people that are symmetrical. For instance, say siblings, okay? If I'm your sibling, you're my sibling, that's perfectly symmetrical. If, on the other hand, it's a direction like parent to child, that's asymmetrical. That's what's called directed. So if I want to indicate that something isn't directed, that it's symmetrical, I just leave the connection here without arrows. But if I want to indicate that there is a directionality to this, I put in an arrow. And it's important to bring this into the picture too, because it might be a situation where you say, well, the relationship might be symmetrical or it might not be. For instance, suppose I ran a survey and I said, hey, tell me who your buddies are in this group. I might name you as a friend, but you might not name me as a friend. So I would have one arrow going from me to you, but not the reverse arrow. And that's important because, again, sometimes there might be something you might perceive as symmetrical, but in fact it's not. And we're going to see an example in just a minute that's going to help us work with this, deal with this. All right. So at this point, we have just some basic ideas to talk about. Now, let's get a few more ideas on the table, okay? So one of the questions is, okay, so suppose you have a network like the one we just saw for our illness, for our disease. How do we talk about it? Well, what might be things that might matter? Well, one thing that might matter, for instance, is say it's a network of friendship and you've entrusted me to get party invitations out to everybody. All right, so how many people I know is going to determine to a large extent how many party invitations I can get out effectively. If I know a lot of people, I'm going to be able to get out a lot of invitations. If I only know a few people, that's going to be fewer. So I need some word to describe this. Well, one of the words that I'm going to use to describe this is going to be what's called sometimes the degree of the network. And by the way, just so you know, I'm drawing this with a trackpad. I don't have my trusty pencil in front of me today, so I apologize for the not so great calligraphic quality of my writing. So what's the degree? Well, the degree is very simple. If I have a node here and I have all of these connections, the degree is simply the count of connections. Now, if the connections are symmetrical, the degree is just how many connections arrive. So in this particular case, I would say the degree is 4. Okay? But suppose they're not symmetrical. Suppose they have a different, I have some coming in, and let's say here, so I have 3 coming in, and I have 2 going out. In that case, I have 2 different qualities. So the in degree, okay, would be 3. And the out degree would be 2. So this is the very first one. And you say, okay, so great. So right off the bat, I can see that this matters. How many people am I connected to? That degree. And it matters whether if it's symmetrical or it's asymmetrical. So do I have separate in and out degrees, or is it just 1 degree overall? Okay. So that's the first thing that matters to me. Great. So maybe that's it. That's all we do is, well, hold on. Here's a situation. So remember, I'm the guy in charge of spreading out party invites to people. And guess what? I know a lot of people. But the people I know don't know many people themselves. So it's a situation that looks like this. Okay, this is me. And I have here, these are all the people I know. So let's say I know 5 people. But all of those people, okay, of all those 5 people, only one of them is connected to maybe, say, 1 or 2 other people. So that's one scenario. Okay, so I have a degree of 5. That looks good. I should be able to do, but I suddenly realize, wait, out of all of those, 4 are dead ends. They get their invitation, but they can't pass the invitation on to anybody else. But what if I look at this as somewhat different scenario? And I say, well, in this scenario, I still have 5 connections, but all of my connections in and of themselves also have a ton of connections to other people. So some of them may be connected with each other, but to other people, etc. Okay, clearly, this is a scenario, the second scenario that I would want to describe in some way, because my degree is the same in both cases, and yet I'm clearly a better person to be spreading invitations in the second scenario than in the first one, right? All right, so this is something I unfortunately can't handle by hand, but don't worry, I'm going to show you how to use a tool to calculate this. And this is sometimes called, or usually called, the Eigenvector Centrality. Very fancy name. If you know your German, okay, or your math, you know where this comes from. If you don't know the German or the math, don't worry. All you need to know is that this is a number, the Eigenvector Centrality. That was very elegant. So the Eigenvector Centrality measures what the connection quality, if you will, to a certain degree is. If I'm connected with people who themselves are well connected, my eigenvector centrality is higher than if I'm connected with a lot of people, but none of them particularly well connected. So this is a second measure. Degree just tells me who I'm connected with. Eigenvector centrality tells me what the quality, what the spectrum of those connections looks like. All right, number 2. So we have 2 numbers here. Now, there's 2 more numbers I'm going to look at, but those are going to be a little easier to talk about if instead of watching my sketches, you actually look at this with some real data. All right? So let's go ahead. I'm going to get away from screen sharing now, and I'm going to introduce you to a new tool. Okay, so I'm going to go to stop share. There we go. Now I'm going to introduce you to a new tool, and this tool is called Vizone. Okay, so now let me put this in screen sharing mode again. And just very quickly, I'm going to first just show you in the browser. Okay, again, I'll give you the website in this particular case, just so you can see it. Here we go. Here is the website for Vizone. Okay. It's a pun, of course, on a visualization of networks. It's Vizone, okay, visualization of networks. But it's also Italian for mink, so therefore Vizone. Very cute. But it's Libre software, so free. You don't have to pay for it, but it's also free to share, etc. For social network visualization. Unlike the tools I used in the first 2 sessions, this one does not run in the browser. There are tools for social network analysis that run in the browser, but they're either harder to use, or they're not Libre, or they lack some of the basic numbers I'm talking about. So in this particular case, it's a little easier to just run this on a machine directly, and it'll run on Linux, Mac, or Windows, doesn't matter which one. And I'm going to show you Vizone in action now, because that's going to allow me to talk about networks in greater detail. All right, so now let me switch to Visone itself. And one more. There we go. All right. So I'll put Visone on screen. There we go. All right. So you should now see the screen from Visone, and you should see a network. Now let me start putting this in terms that you could use in your classroom. So far, I've been talking about networks in general, etc. Let me make this concrete for you. Suppose you have a group of students, and you want to say, well, okay, I want to do a collaborative project among students. But here's the thing. If you're looking at saying, okay, how do I pick? And you just say, well, I'll just grab a student's name from here, another student's name from here. You just put together a random group, say you have about 30 students or so. The odds of your picking a group that works well together are very, very close to vanishingly small, very, very close to zero. And that's part of what happens with group projects. One of the things that's most consistent when you run surveys with students is just how much they hate group projects. And you invariably hear about itself, well, yes, I did all the work, but other people weren't doing this, or you find that everybody had one set of skills, but you needed another set of skills. Part of the issue is you're doing this blindly most of the time. But what I'm going to now talk about is how you would go about doing this with a little bit more information. So let me give you the scenario that this is an actual research data network. I'll give you a little bit more of the history in just a second. And in this research data network, what was done was to say, this is from the work of Moreno. And Moreno said, look, this was a school, a residential school, and asking the students there, all the women who were students there, say, okay, pick your two buddies. So pretend you're going to sit down, for instance, at a dining table. Who would you like to have to your left? Who would you like to have to your right? So everybody at the school picked, this is directional because they picked who they would like to have to their right or to their left. And what you see on screen here, the names, I'll explain in just a second what the circles, etc. mean, but the names correspond to all the names. That's, of course, properly anonymized from the original data set. And you can start to see some of the connections among students. So you can see that Ada, for instance, and Cora, who you see on the left, picked each other. So that's a symmetrical relationship. On the other hand, Ada picked Luis, but Luis preferred to pick Lena and Marion. Okay, and then you notice Marion was very popular. Lots of people picked Marion. Ava was very popular. Lots of people picked Ava. Okay, Robin, not so much, and so on. So basically, this starts to give you a little bit of a picture of the landscape of what this looks like. And you can do this, of course, with your students. Now, you can also do this with faculty. So let's just take a step away, for instance, from students and say you're doing this to build teams with faculty. Let's say you've got a new initiative, and your new initiative is going to focus on, for instance, new uses of technology in education. Well, you might not necessarily want to ask faculty who would be your best buddy to sit by at the dining table, because their best buddy might not know anything about technology, so that would be the wrong kind of network. But you might ask them and run a survey on saying, who are the two people that you would go to if you had a question about how to use technology in learning? And that will very quickly start to give you a network of who is talking to who else in terms of technology. Or, for instance, you might have, as I said, among students. And among students, you might be asking, well, if you had to work on a team with somebody, who would be the two people you would most like to work with? So you're asking the question, but you're not just trying to say, okay, and therefore you do a voting thing. That doesn't work. Because look at this diagram. If we had asked that question here, everybody would want to be on the same team as Eva and Marion, but that's not going to work real well necessarily if you need multiple teams. So we need to get more sophisticated about this. All right. So this is something you can do today. I feel a little bit like one of those mattress salespeople, yes, you too can go out and buy a mattress today. Well, you too can go out and do one of these surveys today. Use whatever tool you like. use the Google Forms, use the built-in survey in Zoom if you're using Zoom to run your classes. It doesn't matter. You're going to get a file. Visone can read in that file. And again, I'm not going to do that now because you don't want me saying, and now I load in a spreadsheet. That's the boring bit. Okay, anybody who has questions, please don't hesitate to ask, but I'll also be putting resources out that will help you deal with that. But let's assume I ran this survey and this is what I got. And now I have this and I say, okay, let's start asking those questions. So you'll see here on the left-hand side that I have a series of tabs, and one of them says analysis, okay? And I have the task is indexing, the class knows centrality, and hey, it's our friend, the degree, okay? And you notice that you have the option of either degree, just the sum of all the connections you have, in degree if you just want the in degree, or the out degree if you want the ones going out. Let's just for a second say we want the in degree, okay? And I'm just going to leave it as it is right now. So I'm going to do this. Sorry, I need to move things a little bit on my own screen here. Okay, so I'm going to tell it, okay, tell me the in degree for all of these different people. I'm going to tell it to analyze. Okay, so it ran the analysis and you're not seeing anything different on the network. Well, that's because you just calculate this. Now we have to visualize it. So let's go ahead and visualize it. And I'm going to go to the category I want is the category called mapping, because I want to take a property I analyzed and I want to map it onto the network. And let's use the node color, for instance. Okay, that's a good choice. So I'm going to use color, node color, and the attribute I'm going to put in is the in degree as a percentage. Okay, and now I click on visualize, so let's see what this looks like. And now you should see on screen pretty much what you'd expect. Marian and Ava, who are very, very popular indeed, have a huge in degree. So they're dark blue. Poor Robin, who's nowhere near as popular, is in very light blue. Ella, who is completely unpopular because nobody picked Ella as somebody to sit with at dinner, is in pretty much very close to white. So you can use the color here to visualize this property, the in degree. So right off the bat now, I could say, okay, even if I had nothing else, I could start seeing, well, who's more popular, who's less popular. Perhaps this popularity will indicate people who are good team leaders, perhaps not. But let's make this a little bit more refined. All right. So the next, let me go back to analysis. Okay, let me just actually take 1 second here and see. So let me get back to. Okay. So the next thing I want to look at then is to say, all right, so I'm going to say, remember that I said that degree didn't tell me, however, who was connected to somebody else by relationships of, well, am I connected with people that are connected to a lot of other people or not? So I'm going to now go to the task of indexing. The class is node centrality, but instead of in degree, I'm going to scroll down and I'm going to find, hey, there's the eigenvector. So we're going to use that. Again, I'll do the eigenvector as a percentage. There are lots of tweaks I could make here. Let's not worry about those for now. I'm just going to go ahead and analyze this. And now I need to visualize this. And now for the visualization, let me use for the mapping, but instead of color, let's leave the color set to the in degree. Let me use the size of the node. Okay. And the property is going to be the node area. Well, it's fine. I'll leave it as the area. And the attribute then is the eigenvector as a percentage. I'll go visualize this. Aha. And now you'll notice something and say, wait, Ruben, the sizes didn't change. Yes, I'm cheating. That's because I had already set the size of those nodes to reflect the eigenvector from before. Okay, just so you can see the change. Suppose I switch off this, I just make the attribute uniform. That's what it looks like if the sizes don't reflect anything other than somebody's a node. If I switch it now to eigenvector, now you can see that. So now things are a little bit more subtle, because even though you have people who are themselves not very popular, who they're connected to nonetheless will affect their relative popularity. So for instance, you can see that Francis, towards the top center of the diagram, is nowhere near as popular in terms of the in degree as Marion, but Francis is connected to well-connected people. So Francis is in and of themselves, even though they're not as popular as Marion, they are nonetheless somebody who is connected to the well-connected. So if I were, for a second, not building teams with this, but instead distributing party invitations and so on, Francis would be a good person to be looking at in terms of distributing invitations. And again, you can use this to interpret further, read the analysis, see what's going on. All right. So let me look for a second here. I will check in the chat to see. Okay, so Brian says, so we can see hubs appear clearly. That's correct, Brian. One of the things you're seeing is hubs are appearing clearly. And Tom says that if you're connected to Ivanka, you're more likely to get a pardon. Well, see, it depends on how pardons are handed out, right? If pardons depend on just being connected to Ivanka, that's one thing. But if they depend on you being connected to other people, at least as well connected as Ivanka, then I don't know. That might be a little different, okay? So we have this, and this already gives you some of the basic tools to start thinking about how you could use this for teams. You should start seeing things along the lines of saying, well, who would be a good choice to, for instance, be a leader? Those might be the people who are in the darkest shade of blue. But who do you want to be acting as go-betweens, as people connected to our connectors? Those would be the people with the sizes of the nodes that are large. And there are other things you might be interested in asking. Remember, you're using this to design a team. It may be a team of students, it may be a team of faculty. So, okay, so what else could we be looking at? Well, one of the things we could be looking at, all right, would be to say, well, okay, I've got the teams, but I'm interested in making sure things aren't too fragile. So suppose, for instance, particularly these days, you're worried about saying, well, suppose I want to get messages throughout the group. Are there people that are more in the path of other people's messages than others? Okay, so this need not be necessarily the person that's the most popular. It need not be the person that's best connected to other people who are well connected. It could be, but it need not be. You're saying, suppose I were to send a message from any one person in the group to any other person in the group. So suppose if you look at the diagram here, I want to send a message from Cora to Ruth. And then I want to send a message from Jean to Ruth. And I want to send a message from Helen to Ruth. And I do all the combinations of all the people that could be sending messages. Are there people that are more frequently in between some of those messages to act as bridges? If they get sick, I may have a problem because my teams may not be able to communicate effectively. So I need to build that in and say, if this person is out sick today, I'd best make sure that messages get there. And again, if you've worked with students, you'll hear that over and over again. I didn't get that message, or I didn't get that information because so-and-so was out, so-and-so was sick, so-and-so's bandwidth was not, their bandwidth was down, their network wasn't working, etc., etc. All right. So that's important to look at. So the third number I'm going to show you then is a number. Let's go back to analysis again. Okay. And the analysis here is for something called betweenness. And betweenness simply measures how many paths go through a certain person. The higher the betweenness of somebody, the more they are in between two messages. And if they drop out from the network, then the more likely it is that if you're sending messages between any two people in the network, that message isn't going to make it. Okay. Incidentally, this also, if we step aside for a second, think of pandemics, might be who is it that I want to get out of the picture as quickly as possible? Who is it that's most likely to propagate a virus? So sometimes it goes in the other direction. In fact, everything I'm saying for building a network for learning applies in the reverse direction for stopping networks from propagating things you don't want to propagate. So let's go ahead and calculate it. So again, it was the between next index. And again, I'll just do the straight percentage. I'm not going to worry too much about strength and so on. So I'm going to analyze this. And now let's go to visualization. And let's use mapping, but now let's go ahead and use color again this time. Okay, let's use a different color scheme because I'm kind of bored of this one. So let me do it in the reds instead. Okay, and the attribute is going to be the betweenness, and visualize it. Okay, and now you can see something very interesting. Betweenness tends to run close in many cases to the eigenvector, but it isn't always the same. So sometimes you can use eigenvector as a proxy, sometimes not. And we could get into a discussion of when that's the case or not. But for instance, look here at Edna. Okay, Edna is fairly popular, not, however, that well connected to other people who are connected. But notice that she's shaded in a quite dark color. So if Edna is sick, okay, towards the center right of the diagram, roughly, if Edna is sick, for instance, Betty is unlikely to get a message, right? Because remember, Betty was other people reaching out to Edna. So this is telling you that if Edna is sick, pay attention. Now, if Marion is sick, of course, lots of messages aren't going to get there, but it's important to realize that it's not just Marion. And again, this is also important. In many cases, it's not just the top tier or the top leadership tier. It's the next tier, but not necessarily measured by the same metric. Okay, so we have now three numbers: the degree, the eigenvector centrality, and the betweenness. I'm going to just give you one more, and then we're going to break out in groups to discuss how you would use this to build up a team activity. The last thing I need to say is, okay, so far so good. I've got all of these groupings. I've got all of these people working together. I now know whom should be the leaders. I now know which leaders are better connected to others. And I know which people, if they drop out of the conversation, are going to interrupt significantly the flow of information here. Fine. But at the end of the day, you might say, okay, with all of this, I still have a lot of work to do to figure out, well, who's more closely connected to whom. I mean, I could start taking a crayon and start making lines around this and saying, well, it looks like these people could form a group and those people could form a group. Wouldn't it be nice if we could just let the computer calculate for us which people are more closely connected to each other when compared to other groups of people that are more closely connected to each other? Now, this is a concept that if I start to discuss it mathematically, we're going to spend the rest of the time on it. So I don't want to get into the details of the math, but it's a concept known as modularity. Okay? And modularity simply says, look, I want people who are more closely connected to each other, but less closely connected to others to form a group. And I want the groups to be, out of all of the possible groups I could build, I want the groups that come out as a result to be the most optimal possible, the ones that have the closest connections between the groups, but the least connections in between groups. It's sort of saying these people are most closely associated with each other, these people are most closely associated with each other, so they form a natural group, and I can distinguish them because they're less closely connected as groups in between. That's, as I say, a property called modularity. But what I'm doing, that's the property I'm optimizing on. But what I'm doing is I'm breaking down the group into communities. And in particular, if I go now back to analysis, the task I have before me is a task not of indexing, but a task of grouping. And the task of grouping, it says, okay, so it's clustering, the measure is modularity, and the method is what's called Louvain, okay? Louvain communities correspond to that intuitive notion I just mentioned to you. In other words, Louvain communities, what the Louvain method is going to do is it's going to pick out the natural communities that tend to emerge from a network. Who's most closely associated with each other and least closely associated with others. So let's go ahead and run it, and you'll see what we get. Okay, so I just ran it, but now I need to visualize it. So here I'm going to use color again. Okay, so I'm leaving size set to the Eigenvector centrality, because remember, that's a very good measure of who is well connected to other people who themselves are well connected, which is a good blend for both leadership, communication among leaders, etc. So that's important. I'm going to say, okay, so category is mapping, type color, property is node color, but the attribute now is going to be not betweenness, but the Louvain communities. And the method I'm going to choose is not interpolation, but a color table. I just want to use different colors, okay? Now you should see already on the left-hand side that we're going to have a total of 5 different communities with 5 different colors. Let's go ahead and visualize. And now you see the picture that results in front of you, okay? So you can see that you have, for instance, the group of yellow is Marion, Francis, and Martha. The group of, looks like periwinkle to me, at least on my screen, is Eva and Maxine, okay? Then you have Cora, Ada, Jean, Robin, and Helen in another group. What this has done is it's partitioned your group into 5 groups that, if your groups don't need to all be the same size, congratulations. You just got 5 teams that among themselves are going to be as well apportioned in terms of connections, in terms of who might like to work with whom else, etc., as you could do by other means. But suppose you don't need 5 teams. Suppose you only need 3. This still tells you how you might divide things up. Because, for instance, suppose you say, well, okay, I've got just Ava and Maxine in that periwinkle group. And actually, I notice Alice and Laura also appear to be there. But I'm saying, who else should I add to that group? And I can say, well, Robin and Helen, suppose I don't need the extra group that's this kind of cyan shade that has Ada, Cora, Jean, Robin, and Helen in there. I can say, well, I'm going to send, I guess, Robin and Helen and Jean to the periwinkle group, and I'm going to send Cora and Ada to the yellow group with Louise, Lena, Marion, and Francis, and Martha. So it gives you both the basis for a natural partitioning of what you would have into teams. But it also gives you the basis for saying, well, if for whatever reason I don't want to go, or I need more teams, or I need fewer teams, or I need different teams, it gives you a logical basis for doing this or for working with this, rather than just saying, well, okay, I'll just roll the dice and get this. So it gives you the basis for a kind of rational approach to team building. And I've done this with students, and it works really well. Is it perfect? No, you're always going to have some scenario where you have some student that doesn't really fit, frankly, no matter how you divide up the teams, but you're closer to a fit than you would be otherwise. In other words, even in those scenarios, it's easier to do so. And remember, here we just said people who like each other, but suppose you're talking about capabilities, competences. Suppose the question you asked was the one I was mentioning for the faculty. Who would you go to if you had to figure out how to teach a certain topic using new technology tools? Then that's also giving you a basis for seeing clusters of people. And then you might do additional things. You might say, gee, let's assume I asked that question in this diagram. I say, I noticed Francis, Marion, and Martha and Lena and Louise would all kind of go to each other. Let's run a mini survey on them and find out more. What type of tools are they interested in? Because that might tell you, oh, these are the video specialists, so I should have them work together as a team. But maybe for another one, I want to say, no, I want to separate them out into multiple teams, But again, I'm not going to send, say, Luis to work with Ruth because Luis and Ruth have nothing to do with each other. I might say, well, Ada and Luis might work if Ada, Cora, Jean, Robin, and Helen were, for instance, the interactive media group, okay? Because I know Ada and Luis are fairly close to each other. In other words, it also gives me a basis for recreating, reapportioning teams based upon this. All right. At this point, I've been talking for a while. I want all of you to be working for a bit. So let me stop sharing now for a second, and I'm going to give you a task, and we're going to go to breakout rooms to do that. All right, so let me look at the chat again, make sure I can see this. And let's see. Okay, so Brian, yes, there are sample files. I'm going to send you links to the sample files. I'll tell you right now, here, I'll type this right here. I don't have the URL immediately handy, but there's a piece of software for analysis called Pagic. Okay, and I just typed the name over there. So Pagic is yet another open source software. However, it is more limited in which platforms it runs on. It primarily runs on Windows. You can get it to run on the Mac, on Linux, but you have to do a little bit of sleight of hand with different libraries, etc., to do so. But one of the nice things about the Pagic website is it has a ton of sample libraries, including the one I was just showing you, by the way, which is from the work of Moreno, that you can use to play with. So you can do this. And I'm also going to show you in a little bit after the task another way of getting data from a survey that I think you may find useful. Okay. So yes, I believe that, yes, that is correct, Brian. Thank you. So those are some sources. And again, I'm going to encourage you really to make your own and so on. I did consider having us do a survey and so on, but the amount of time it takes, to me, the trade-off, the cost-benefit ratio was such that I decided, okay, let's not do the survey here. But I will show you in just a second a survey you might have some fun with and you might want to run on your own. So that was for Brian's question. And then Tom says, wouldn't it make sense to use the connected people to form intersections between groups? Absolutely, if that's what you're looking for, Tom. So if you're looking to say, okay, so each team is going to be doing tasks. One of the things you can do is have different teams do different tasks. I've never quite understood why people insist on having every team do exactly the same task. That may be appropriate in some cases, but in many cases, it's more interesting if you say team X does this, team Y does that, and then yes, the connected people can act as the bridges to say, okay, they're the people you trust to bridge between the groups, to share between groups what the knowledge is. And as we're going to see in just a bit, there's one more set of data that you can use for that. All right. So let me break you all out into groups. So Laura is going to handle the master discussion here. And what we're going to do is break out, I think, into two groups. And here's what I'd like you to do in your group. You now have a lexicon for talking about social networks. You know how to run a basic survey. You know what information you can get. You can see how it might visualize it. What I would like you to do in your groups, and we're going to spend, let's say, 10 minutes total on this, is to pick a task, whether it might be a class activity with students, an institutional activity with faculty or staff, or I'll leave it up to you if in your group you find something else that you would like to discuss, but talk about how you would build up from a survey to using these metrics to what you would have them do specifically because you have this information, because you have this way of looking at things that you would not otherwise. Okay, so again, the task before you is pick a task that you might do with a group of students or a task that you might share among faculty, or if you want to say, suppose you're working with items such as figuring out a broadband initiative at the state level and you want to distribute tasks among the group, that could also be a possibility. Well, what you do is design a survey that will ask a question that will be relevant, and then think how you would use these 4 parameters I gave you, the degree, the eigenvector centrality, the betweenness, and the Louvain communities, to decide how the task would be accomplished. All right? Is that clear? Any questions, please type them into the chat space before we break out into subgroups. So we're going to break out into 2 breakout rooms, and I'm going to try to go between the 2 rooms. So again, the four terms here, sure, it's degree. So degree, eigenvector centrality, betweenness, and the Louvain communities. Let's see, I think we should have everybody back with us right now. Okay, so I'm looking into the chat space and seeing quite a bit of commentary taking place. So Lisa saying, loving the idea of change agents and how they can be the popular people's best choice to communicate out the ideas. And the betweenness is a great focus for my issue. When you messenger is out for any reason, there's a gap of information and we need multiple agents, absolutely providing and disseminating information, absolutely. And again, betweenness works well. Brian is doing promotion for group 1 as well. He should. All right. So looks like I'm just doing a quick count here. Yes, everybody's back. Good. So sorry for the slight delay. We had a little bit of a Zoom glitch there. So what I would like to ask is one person from group 1 and one person from group 2, if you can do a quick 3-minute précis of what you discussed in your group. And then I'm going to show you one nice additional trick that will address some of the questions you had in both groups. So whoever would like to go from group 1?
I'll go from group 1, the best group. We had an interesting set of examples that were varied by scale. The smallest example was taking a look at an individual seminar, so a class of up to 20 students. The largest example was looking at information flow through an entire university. And in between, we had the idea of trying to work with a faculty population to accomplish a certain goal. We looked at a few different tools for this. One of them was trying to understand eigenvector centrality, or sorry, trying to use eigenvector centrality in order to identify change agents. And these are people who would be critical in pushing ideas or information through, and their non-participation would be critical and sap information flowing. We also talked about degree and thinking about a degree as a way of understanding, basically in many ways something similar, trying to understand where the major transmitters and receptors of information would be. And then we also had a great side project from Paul and Ruben to apply all of this to another Shaping the DU project, but I'll leave them to talk about that. Group 1, how'd I do? Did I miss anything?
Thank you. That's a great summary. So how about group 2? Who would like to? Who would like to go from group 2?
I can try to recap what we did. I don't think we got as far as group 1, but basically, so we took Tom. It teaches a class on government and public policy. And we decided of 2 ways he could group his students. Either the survey could indicate their preference for what public policy they'd like to follow or what social issue they'd like to follow, and they could be grouped that way. Or it could be, the survey could ask for student strength, and then they could be grouped by like somebody likes to do research, somebody's good at writing, that kind of thing. And you could pair the groups according to having a different strength from each person. And then the tasks amongst the students. So what Tom essentially does is to try to create social awareness through this semester-long project where students are researching a social issue and how public policy and government impacts that issue, and how creating resources, taking it from one and applying it to another might change that structure a little bit. So the task the groups would have would be to implement that kind of problem solving.
All right. Excellent. So again, thank you both. It's a great summary of both of the groups. So thank you both for doing that. And again, the goal here is to start getting you thinking about this, thinking about what can be done with the tool set. Because in particular, I think both of the groups in the conversation found that some questions came up, such as how do you design the survey? How do you ask some questions? How do you get multiple capabilities into the picture? One of the reasons I like to do the exercise at this point rather than later is because now what I'm about to show you has a motivation for it. Because I'm about to show you a way to get at exactly that question. The question of how you get at the, well, geez, it's hard to ask this question. I don't have an easy way. My students are coming in and they don't know each other, so I can't ask them which student would they like to work with and so on. Are there other ways we can do this? Sure. And one of the ways of doing this, I'm going to go back now to my oh so beautiful whiteboard. Okay. Is to say, well, hold on. Could I do some things by thinking not necessarily about asking a survey or a survey that asks something about a person? Do you know this person? Do you want to work with this person? Which people would you like to work with? But to say, well, what about things that you have in common with other people that you may not even know you have in common with them? So for instance, let's take Tom's scenario. Okay, so Tom and his group are discussing, okay, so my students come in, first year students, they don't know each other. So asking them in a survey, who would you like to work with, is unlikely to be very useful. But one thing you might have for some of these students is you might be able to ask them, well, which courses did you take? And use those as common elements of interest, right? So if I'm going to draw this now, okay, so I have here student A, student B, and student C. And I have courses, and I'm going to put here 2 courses. Okay. If student A took this course and student B also took this course, and student B took this course and student C took this course, then you can say, wait a second here, because since these 2 students share this course and these 2 students share this course, then what I have is effectively something that's telling me that there's a connection between student A and student B, and there's a connection between student B and student C, but not between student A and student C, assuming they have no other courses in common and so on. So this is a way of getting at something I might not otherwise see by saying, well, what do they have in common? I could look at courses they've taken. I could look at projects they've undertaken and classify them and say, well, these students have done this type of project, these students have done these types of projects, and then say, well, students who've done the same type of project have at least some type of commonality between them. You could also have it be that the more students, the more projects or the more courses students have in common among them, the stronger the connection between them. So let's say that these 2 students not only shared that course, but they also shared this other course over here. Okay. And now I might say, oh, okay, so those students now have a much stronger tie than the students who only shared one course. So I might say they have a tie that's twice as strong as this one. I might even say, draw it in really fat marker here to indicate there's a really strong tie between the students that shared more than one course and the students who only shared one course by themselves. So this is a second way of creating networks. A way of creating networks by seeing what do people have in common, or you might ask them questions that while they don't relate to each other, do relate to what they might want to do. So you might ask them, for instance, about shared interests. You might say, here's a list of books that I know you've read because they were requirements for all the students. If you had, say, a FIPSI project, there's a project I did some years back where we had all the students read a common set of books. Well, out of these books, which 2 out of these 10 books, which 2 did you find the most intriguing? Okay, so you take that and say, well, students that have one book in common with somebody else, have a connection of 1 to them, and students have 2 books in common with somebody else, have a connection of 2, so a stronger connection. So let me show you, for instance, how you might construct. I'm going to stop sharing my whiteboard now. So let me do that. Let me show you, by sharing my screen now, how you might construct one of these types of surveys. And I'm actually going to give you a link to this one if you want to try it with your students or your faculty or your whatever, administrators, whatever group you're working with. So I'll switch now to Safari one more time. And I'm going to show you now a very important and crucial question. This is the, drum roll please, make your own Sunday survey. Ta-da! Make your own Sunday survey. You've never asked a question as important as this. This is a survey I use, and again, we need more time. This is typically when I'm working on a day-long focus project, I bring this in. But it's a project, it's a survey I run with people. You'd be surprised how much information you get. You know, it's a silly little thing like this. And you say, okay, it's a 3-question survey. And I've run this in quizzes, I've run this in Kahoot, I've run this in Google Docs, I've run this in Zoom. It works like a charm in all of them. And it says, okay, so make your own sundae with 2 scoops of ice cream and 1 topping. All options are available. And vegan or lactose free. I obviously add that in so people who are vegan or are lactose intolerant don't feel left out of the picture. So what would you like for your first scoop? And I have 4 flavors. Then what do you like for your second flavor? And I have 4 flavors. I'll come back to how I choose these because it's really important how you choose this. Believe it or not, even for a silly little thing like this, you need to pay some attention to this. And finally, what would you like for your topping? Okay, first things first. I didn't choose these flavors at random. I actually reviewed, I'm not joking about this, 10 years of data from the dairy industry about ice cream to find out what the shifts in popularity had been of flavors. And I also found data on toppings from, say, from the ice cream industry. So this is all based on actual research data, believe it or not. And one of the things that you want to do when you do something like this is you'll say, well, okay, you got mint chocolate chip, butter pecan, coffee, Rocky Road, coffee, but hey, there's no chocolate, there's no vanilla. Did you forget them? No, those are too popular. If I put a flavor like that on a survey, it immediately wipes out the utility of the survey because everybody likes some chocolate, or everybody, you know, the top 4 or 5 flavors, they're so popular that you don't get very useful information out of it. So everybody, you put vanilla on there and well, that's it. You've just kind of wiped out your survey. And this is important to realize. The same thing can happen with students. If all students in your college are required to take Writing 101, then putting Writing 101 on the survey does you no good because everybody had to take it anyway, or even if it's a most people. So you want to make choices that are not so exquisitely rare that nobody is going to have them in common with anybody else, or people are going to be scratching their head and saying, what is this? I was reading an article about why you don't have grape ice cream the other day. So I didn't put grape ice cream here, and I've never found it grape showing up on any surveys for ice cream. This is sort of an intermediate tier of flavors, and they are organized so they're of comparable popularity. So mint chocolate chip, butter pecan, coffee, and Rocky Road are all of comparable popularity to each other. Cookies and cream, cherry, peanut butter cup, and pistachio are all of comparable popularity to each other. None of them are top of the pops. None of them are who on earth wants to eat that. So this is important as you're setting this up together. As I say, you can have a lot of fun. Please feel free to take the survey. I'm going to put in the blog post a link to this so you can download it, use it for your own purposes, etc. And the same thing with the topping. These are not either in topping, it's a little bit more diffuse, so you can do things like put in sprinkles and you'll still be okay. It's not a problem. But for instance, if fudge is too popular, you can't use fudge. So this is how you would construct this. And then you say, well, again, I showed you that diagram where I was sketching on the whiteboard a minute ago. And you can see that if I have 1 flavor in common, I have a connection that's 1 strong. If I have 2 flavors in common, I have a connection that's 2 strong. And if I have the both flavors of ice cream and the toppings, I have all three, then I have a very strong connection. So what I'm going to do now for the final wrap up here is, if you're wondering, I'm actually going to show you the results of one of these. So I'm going to share now back on screen. Okay, I know somebody, yes, basil ice cream. I have actually had that, believe it or not. You're right, it's very good. But I'm not sure I would have it as a dessert. That's kind of a special on its own type treat. Okay, so let me go ahead and call up Visone. And I'm actually going to show you, this is an actual result from a time I ran this about a year ago. And here's what the diagram looks like. This is, once again, true research data. I'll also make sure it's already been anonymized, so you can go ahead and use it. You'll notice that some of the names, like Boom and the Queen, are not exactly very serious names. That's fine. This is actually a group of very serious people that participated, but they all took it with a good sense of humor. And you can see right away that you have all of these connections. So very simply, just to show you one very simple example, let me just do a very quick Louvain analysis on this, okay? I'm just going to run a quick Louvain analysis so you can see this in action. Let's go to visualization, mapping, and here's an interesting thing. In this particular case, the Louvain communities turned out to be just one. So we're going to have to use other criteria. In other words, this particular group is so interconnected that they all form a single community. So if I were looking to subdivide among groups based on ice cream, I'd say, you know what, these people just all want to share one big table for the ice cream. And that's also an important result. It's important to realize that. Some people say, oh, but that's a problem. No, no, no. That's very good. It's telling you that it's a group that has, within the parameters of what I was researching, a common shared self-interest. So very quickly, just so you can see, for instance, if I switch this, the measure, instead of grouping, I'll just do quick indexing, and I'll do the index going for eigenvector. Analyze this, and now let's get back to visualization, mapping, size, eigenvector, visualize. Now you can see, if you look towards the top, for instance, okay, Emily is a bit smaller than Beth towards the middle. Now, I'd probably redo this diagram with more time, use scaling factors to visualize it more clearly, but you can see that from this, you might start to identify people who might be leaders in the ice cream choice area, who say, well, everybody is going to share things, but these are going to be at the head of tables and then communicating with others as to the ice cream sundae flavors created at their tables. So that's an example I wanted to show you. Let me now stop sharing here. Okay. So that's an example I wanted to show you, so you could see how you would go about creating something, creating a survey or looking at existing data that would in and of itself give you this type of information, in and of itself show you the network that exists among people, and show you, in some cases you will get communities, Louvain communities, in other cases you won't. In some cases you'll get some people that immediately stick out as, okay, these are the leaders. In other cases it's going to be, well, it's more of a diffuse function, but I can still get information with this more subtle ranking, and so on. So that's the last bit I wanted to show you about this. And that's what I wanted to leave you with, this idea of how you can take it a step further. And you just have, as I say, there's many, many, many other numbers you can use for social network analysis. But if you take these 4 parameters, okay, 3 numbers really and 1 partitioning of this set of people, and these approaches to how you either do a direct survey or you construct, and again, I'm going to give you resources so you know how to bring this data into Visone, how you can take these data from things like shared tastes, shared courses, surveys about shared interests, etc., and use them to build networks. You have a powerful tool for building experiences, building networks, building teams that don't fall apart, that aren't, oh my God, why did I get put together with these other people in this team? This is terrible, etc., etc., but they instead really work well together. So that's about it. And I also want to invite you all, in closing, to the next phase of the Black Swan project. This first phase was to introduce the key concepts. the idea of system dynamics, the idea of agents, and the idea of networks. The next phase is going to be an intensely applied phase, and you're all going to be receiving information about it. It's going to be a phase where we're going to go into a studio mode, where I'm going to be inviting those of you who would like to participate to design a project, and we're going to be using this tool set together with SAMR, the other model, one of the other models that I've developed, to say, how do you build then approaches, tools, solutions that aren't just responses to black swans that more or less hold together, but are actively anti-fragile, that come out the other side of the experience with better objects, better constructions. So that's what I'm going to ask you to keep an eye on your emails for, because I really would like to invite you all. I want to thank you all for coming today, for being willing to do the breakout sessions in the rooms, discuss, think about all of this. And now, of course, you're all going to go off and start looking to see what ice cream you have in your respective fridges, right? But I want to also invite you to the next stage, and a stage of not just talking about this, getting the basic ideas, but actively creating a studio stage where we'll be sharing what we'll all be creating in this arena. All right, so in closing, I'm doing a very quick last scan through the, I'm glad to see mint chocolate chip is popular. I'm looking through the chat to see if any other questions or comments have come up. All right, so I think that it looks to me, okay, so there's a question from Lisa about if you have a larger group, is it important to have a larger number of options for each question? It's a very good question. It depends on the type of group. In some cases, yes. In other cases, no. You have to be a little careful because if you're pretty sure that everybody's going to have at least an option that they find acceptable, you're better off with fewer options rather than too many. Too many, and you start getting a very wispy network. You start fragmenting it, diluting it too much. But if you have too few, if somebody's saying, well, geez, I hate all of these flavors of ice cream, then you may not have enough. So there is a little bit of a trade-off. Again, my experience, this particular survey, I've actually designed it, and I've actually asked people, would they use that? Because there's a group that was meeting later for dinner, and people were enthusiastic to actually assemble some of the ice cream sundaes. So I'm pretty comfortable that it's about the right number. But for other things, obviously, you might need more or fewer. Let's see. So, all right. Will I be carrying any of this into the Shaping EDU Winter Games? Well, since you brought this up, Paul, as you know and I know, we'll all be talking about broadband, the broadband project, as part of the Winter Games. And yes, some of these ideas are ideas I hope to discuss in our session, which is going to be a conversational session about the broadband project and how that's evolving. So let's see. I think that's about it for all the questions that have come up. So if that's the case, let me all thank you all for coming. I'm also going to wish you all a peaceful, safe, relaxing season for whichever holiday or celebration you might choose to have at this time of year. And I hope to see you all at the Winter Games, and as I say, in 2021 for the studio sessions, and to continue our discussion around black swans. So thank you all for coming, and looking forward to seeing you all soon. Thank you.